Alright, this is objective 2. This is the third video for 8.3. It says solving an equation quadratic in form. Remember the quadratic formula is ax squared plus bx plus c. Some of you may have used the brute force method, which is basically just guessing if you have something in front of x squared, or you can use AC method. Khan Academy on YouTube has some great tutorials, so if you don't remember how to do this, just go up there and look up factoring. So let's go ahead and look at this example. Solve the equation 2 sine squared theta minus 3 sine theta plus 1 equals 0, where theta is a value between 0 and 2 pi. If you don't like all the signs in there, what you can do is use substitution. Just say let x equal sine theta. If you do that, you get this: 2x squared minus 3x plus 1 equals 0. Now that looks like something we could handle. At this point, you can use the guess and check method, which I call the brute force method, or you can use the AC method. The AC method says that you take the a value from the general form, which is ax squared plus bx plus c, and multiply them together. So if I do that, I get 2 times 1, which is 2. And now you factor out, or you figure out the factors of 2. The only factors of 2 is 2 times 1. And I'm trying to figure out, when I add these together, do I get 3? I can get a negative 3 if I add negative 2 and negative 1 together. So what the AC method does is it takes your middle term and it replaces it with these two factors. So instead of writing negative 3x, I'm going to write negative 2x and then minus 1x plus 1. And now I can use grouping. And grouping says I group the first two together, and I'm looking for GCF, and then I group the second two together and look for a GCF. So in the first grouping, the GCF is 2x, and I'm left with x minus 1. And in the second grouping, the answer is negative 1 that I have common to both, so I'm left with x minus 1. Now when you do the grouping, inside the parentheses have to be exactly the same, which they are, so I can GCF, or take the greatest common factor out again, which is that x minus 1. And I'm left with x minus 1 times 2x minus 1. Okay, your last step is to check it. So you FOIL it out. X times 2x is 2x squared. That's my first term, so that's good. My middle terms are going to be negative 1x and negative 2x, so that equals negative 3x, and then negative 1 times negative 1 is a positive 1. So that all checks out. So now you got to solve. So I'm going to resubstitute in x equals sine theta. So I have sine theta minus 1, and I have 2 times sine theta minus 1 equals 0. And now I have to solve this. So you're going to use the 0 property. The 0 property says anything times 0 equals 0, so a can equal 0 and b can equal 0. So a would be sine theta minus 1 equals 0, and I have to solve for that. So sine theta equals 1. If you look on the unit circle, look for where sine equals 1. And you're going to find that sine equals positive 1, where theta equals pi over 2. So there's one of my answers. My second answer is, if I use the 0 property, that's going to be b. So b is 2 sine theta minus 1 equals 0. 2 sine theta equals a positive 1. Sine theta equals 1/2. Remember that sine equals 1/2 in two places, quadrant 1 and quadrant 2. So in quadrant 1, theta is going to equal 30 degrees or pi over 6. In quadrant 2, theta is going to equal 150 degrees or 5 pi over 6. So my answers for this are going to be pi over 6, pi over 2, and 5 pi over 6. So I have 3 answers that work with this. Okay, so let's go ahead and move on to objective number 3, which is using the fundamental identities. So sometimes to be able to solve the equation, you have to be able to do like everything. So the first thing I'm going to do is I'm looking at this, and because I have sine squared, I'm going to leave that there, but I'm going to move everything over to the same side. And the reason why I'm doing this is because I know I have a quadratic formula here. I have a problem. I have both sine and cosine mixed together. So I have to get everything in either all sines or all cosines. So that's going to be step number 1. I think I'm going to go for cosines because I have sine squared here. And I can use substitution, and I can use a Pythagorean identity, which says sine squared theta plus cosine squared theta equal 1. So if I get sine squared theta by itself, it's going to equal 1 minus cosine squared theta. So I'm going to use direct substitution here, and wherever I see sine squared theta, I'm going to plug in 1 minus cosine squared theta. Minus 3 cosine theta minus 3 equals 0. Now I'm going to distribute. So I have 2 minus 2 cosine squared theta minus 3 cosine theta minus 3 equals 0. I'm going to combine like terms. So I get negative 2 cosine squared theta minus 3 cosine theta, and then I have minus 1 when I add negative 3 to a positive 2. At this point, remember, if you want to use the AC method or whatever you want to use, you should have that leading term in front of the squared value being positive. So if I multiply by negative 1, I get 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. Now, let's let x equal cosine x, or cosine theta, excuse me. So I'm going to write that up a little bit nicer. So now I have 2x squared plus 3x plus 1 equals 0. Now I'm going to use the AC method. So once again, I'm going to multiply that a term, which is 2, times that c terms, which is 1, which is going to equal 2. Now I'm going to find the factors of 2. So the only thing 2 factors into is 2 times 1. That does equal 3. Because if I add 2 and 1, I do get 3. So this checks out. So they're both positive. So I'm going to replace that middle term with of 3x with 2x plus 1x. And now I'm going to use the grouping method. So the grouping method says that I combine the first 2 together and I combine the last 2 together, and I find the GCF. So the GCF of the first one is going to be 2x, and I'm left with x plus 1, and the GCF of the second one is a positive 1, so I'm left with x plus 1. So I get 2x plus 1 times x plus 1. Now I got to solve that. So before I solve it, I want to go ahead and replug in cosine. So 2 cosine theta plus 1, and I have cosine theta plus 1 equals 0. At this point, I am going to use the 0 property, but I need some room. So I'm going to go ahead and erase off this part here. And I'm going to leave that up because we need to look at that. So let me just get a nice clean slate here. So I'm in the process of solving this. I'm going to use the zero property. So my a value is going to be 2 cosine theta plus 1 equals 0. So I have 2 cosine theta equals negative 1. Cosine theta equals negative 1/2. Cosine is negative in quadrants 2 and 3. So in quadrant 1, if I use a triangle, theta is going to be 60 degrees. So that's pi over 3. So if I move that to quadrant 2, that's going to be 2 pi over 3, and that's quadrant 2. And in quadrant 3, theta is going to equal 4 pi over 3. So these are my values where cosine equals negative 1/2. Now I'm going to look at the b portion. The b portion was cosine theta plus 1 equals 0. So cosine theta equals negative 1. If you look at the unit circle, there's only one place where cosine equals negative 1, and that's at pi. So my answers for this one are going to be 2 pi over 3, pi, and 4 pi over 3. And I'm done with that one. Okay, so finally this last problem says solve the equation cosine squared theta plus sine theta equals 2. So once again, I have to make sure that everything is in terms of sine or cosine. So what I'm going to do is use substitution using Pythagorean identity. Remember, it's sine squared theta plus cosine squared theta equal 1. So I want to get cosine squared theta by itself, so this is going to equal 1 minus sine squared theta. So I'm going to use substitution. So cosine squared theta, I'm going to substitute that in for 1 minus sine squared theta. Now I have everything in terms of sines. So if I put this in order, I get negative sine squared theta plus sine theta plus 1. And then if I move the 2 over, I have positive 1 minus 2 equals 0. So now I get negative sine squared theta plus sine theta minus 1 equals 0. And remember, we have to multiply by negative 1 because I do not want the leading term to be negative. So when I do that, I get sine squared theta minus sine theta plus 1 equals 0. And now I just have to factor this out. So once again, before you factor it out, let's let x equal sine theta. So if I do that, I get x squared minus x plus 1 equals 0. Now factor it. X squared is x and x, and 1 only factors into 1 and 1. And my middle term is negative, my end term is positive, so both of these have to be negative. But when I check this, I get x times x, which is x squared, x times negative 1, which is negative 1x, x times negative 1 again, which is negative 1x, and then negative 1 times negative 1 is a positive 1. So I get x squared minus 2x plus 1. That does not equal x squared minus x plus 1. So this does not factor. And let me write that a little bit nicer. It doesn't factor. So when that happens, that means that there is no solution for this. Okay? So, by the way, that doesn't happen too often, but here's an example of it happening and what you do with that. Okay? So it's always good practice to FOIL out what you have to make sure to see if it works or not. Objective 4, it says solve using a calculator. When you do these, you have to graph this. So what you do is you put the first equation equaling the left-hand side, and then the second equation, you're going to let that equal the right-hand side. So on the calculator, it usually says y1, so you let that equal 5 sine x plus x, and y2 is just 3. And what you're trying to do is find where 5 sine x plus x and 3 intersect. That's going to be your answer. So to do that, you use the math function and then you click on intersect. So that's how you would do these problems. So you're looking for where the two intersect. If you use Desmos, you would do the same thing where you enter in y1 equals and y2 equals. And then you're just going to go up and find out where the two lines meet. Or I should say the two functions meet. Okay, so that's it for this section. By the way, you will not have a question on the test that says use a calculator, but you may have that on homework, so just want to make sure you're prepared for that. And that's it. All right, so that's the end of